right, guys, I'm so sorry I got cut off. So apologize for that. I had to stop the video at the point where we had left off. So I hope that it actually makes sense because I know it's like joined together. But yes, I'm actually wrapping up the video on another day. So you can see that there's a change in the tone of my voice apparently. And so we're going to pick up from where we had left off at this stage of the tutorial review, the assessment paper review. All right. So let's just quickly go back through here. I know it sounds a bit weird because I would have essentially gotten to this point where we are grouping like terms. And so we're grouping like terms here. We see 10x minus 9x minus 2a plus 4a minus 3ax plus 2ax. All right. And we were saying that we are going to be grouping like terms. All right. So, and we've done that. Then we know that 10x minus 9x is going to be x. And then again, I'm going to put this into groups of 2 here, guys. Okay. When you're doing this, you want to do that just to make it easier for you. Okay. And so we're going to go ahead then and say 10x minus 9x is going to be x. Oh, I need to write that a little bit better. So that's going to be 10x minus 9x is x. Now, negative 2 plus 4, I find quite a bit of my students actually writing negative 6. So you've got to remember that the negative 2a is an amount that you owe and the positive 4a is an amount that you have. So paying that, you're going to still end up having 2a's left. All right, and negative 3ax plus 2ax, that's going to give us negative 1ax. We'll just write negative ax, and this is your solution. All right, so I hope you guys got that one and you finally understand what we need to do to get to that answer there. All right, getting to the most interesting part of the question then, we're going to be looking at this question here. Give me a sec. So we're going to be looking at this question here. So we have 6p, right? Let's get this here. 6p. Oops, pardon me. Here we go, guys. Okay, here we go. So we have 6p. I don't know why my screen is jumping, guys. Pardon me. Forgive me. Just a second here, guys. For some reason, I decided my pen is not going to work. So let's figure this out. We need to close the screen and come back. Just give me a second here, guys. All right. Let's do that. So it does have some time when the screen tends to go out. So just give me a second. Let me pull up the assessment document. And don't remember, guys, do not forget to subscribe to the channel, share this out. There are many persons that is, of course, in need of the help. You know, not many instructors are going to take the time out to go through an assessment paper to ensure that you have a thorough understanding, and even the fact that you can actually watch this again and again and again and again to ensure that you guys have a thorough understanding of the topic. So I think we are back at it, guys. Here we go. So zooming up here. All right, here we go. So now we're ending up with 6p to the 2, q to the minus 2, multiplied by 2p to the minus 4, q divided by 4p q to the minus 1. All right. All right. So for this question, no, a couple of my students actually got it right, but the layout for me, I think the layout was the challenge for many persons. They started to confuse themselves a little bit in terms of how to write it down. So pay close attention, guys, to how you work out questions like this in a sequential order. So have a look, guys. First, I'm going to take out the numbers. I'm going to say 6. Hold on, guys. I'm going to go ahead and say 6 multiplied by 2 divided by 4. I'm going to place that into a bracket like that, guys. Okay. Then I'm going to extrapolate the p's. So the first p is going to be p to the 2. And it's being multiplied by the second p, which is p to the negative 4. And then it's going to be multiplied by, sorry, it's not going to be multiplied, it's going to be divided by the third p. And that's going to be p. And remember that there's a power here. You don't see it, but it's understood to be a 1. So that's going to be p to the power of 1. I'm going to write that 1 right here so we can see it in our calculation here. All right. We're going to tie them together now with a multiplication sign. So we're going to say then q now. So the first q is this q right here, q to the negative 2. It's being multiplied by the second q, which is q without a power. So that's power of 1 right here. So that's q to the 1. And then it's going to be divided by q to the negative 1. So essentially, guys, for those of you students who have got a chance to actually do this paper, you would have been getting it incorrect because your layout would have not looked like this. And essentially, there's going to be sign clashes potentially, or there might be some adding of negative and positive numbers. So you have to be very mindful. Let's go ahead and see 6 times 2 is 12, and 12 divided by 4 is 3. All right. Now we know we're going to rewrite back one of the p's because the bases are the same. So the first two powers, we're going to be adding them because of the rules of multiplication. So that's p to the 2, and we're going to be adding the negative 4 to that. Okay, we're going to be adding negative 4. All right, and why are we adding again, guys? We're adding because multiplication requires us to add the powers. But the third p, then we're dividing. So we're going to be subtracting 1. We're going to be subtracting this 1 right here. Okay, and then we're going to have q then. Then we're going to have q to the minus 2, the first power. The first powers, you're adding powers. So that's 32 plus 1. And then the last one, we're going to be dividing, say here. We're going to be dividing, let's see here. We're going to be dividing. So because we're dividing, I don't know why I wrote that division here, guys. Because we're dividing, we're going to subtract the third power, which is subtracting negative 1. Right? So if you find that challenge getting to the answer, guys, it is essentially because you don't have this sort of layout. You're going to find it very challenging, especially when algebra is a weak area in your area of skills. So when you do it like this, you're going to find more success. All right. So final answer then is going to be 3p. You can type all of that on your calculator. You should end up with negative 3. 2 plus negative 4 is negative 2. Negative 2 minus 1 is negative 3. And then you have q. Negative 2 plus 1 is negative 1. Negative 1 plus 1 is going to be 0. Now, some of you wrote 3p to the minus 3, q to the 0, or you could just simply write 3p raised to the minus 3. Right? If you just wrote down q and left it like that, you can lose a half a mark. I know what you're trying to do, but you can't just leave nothing there and just assume that it means 0. Right? If you leave q there, this is implying that q is raised to the power of 1. So you have a choice. You can write the q to the 0, or you can just eliminate the q to the 0 altogether, and your new answer is going to be finally 3p to the minus 3. All right, so that's essentially how you work out this question then. Okay, let's move on to the third one. I kind of did like a little flip script of it, right? Little flip script. So that's 15a. So what I did here, as you can see, I kind of just put the division here instead, and then put the multiplication there instead. That's what I did. So just to give the students another chance at getting it right. Right. And let me know in the comments, guys, do you think that this was a challenging paper? Was it a challenging paper? Was it challenging because you didn't practice? Was it challenging because you didn't get the concepts right in class? Or is it just challenging simply because you are really, really not good at math and you just can't find a way to fathom the concept? Let me know in the comments. I would greatly appreciate the review. And let me know what else I can do to kind of help you guys to understand a little bit more about the content, okay? So we're going to go ahead here and zoom out. I'm going to write this here. So we're going to have 15 a to the minus 2. I'm going to zoom it up back a little bit, guys, in a second. 4 divided by 2a, pardon me. Okay, we're now divided by 2a, y to the minus 5. Oops, oh, I don't know where that zoom out, guys. Wow. Okay. So 2a to the minus 5. And then we're essentially going to divide this. We're going to multiply this then by, I'm going to multiply this by 2. This was actually a mistake, because I didn't really want a decimal value to come out. But it essentially worked out to be a whole number. I actually, to be honest, when I was typing up the paper, my intention was to actually get this number to be a 3. So I wanted to be 15 divided by 3 times 2. But nevertheless, it's a math problem, so it can always be evaluated. Okay, so let's zoom it up here. Let's get into the meat of the matter. Here we go. So again, remember guys, you're going to take out the numbers. So that's going to be 15, right? Divided by 2. And then you're going to multiply it back by 2. It's kind of undoing what you did. It's like dividing and multiplying. It's just undoing. So the answer is obviously going to be 15. All right, so then we're going to extrapolate the a's. So the first a is a to the minus 2. And then it's actually being divided by the second a, which is a to the 1. Notice that there's no power there, so it's going to be understood as a 1. And then we're going to multiply it by the final a here, which is going to be a raised to the minus 1. All right? And so with that said, now we're going to move on and tie this together with a b, with the y, pardon me. It's going to have y. And the first y is y to the 4. This is the y that we're looking at now, y to the 4. We're going to divide it by the second y, which is y to the negative 5. We're going to multiply it then by y to the 3. All right. Now with that said, 15 divided by 2 times 2 is still going to be 15, because 15 divided by 2 is 7.5. 7.5 times 2, that's going to still be 15 here. All right. Now all 3 a's, the bases are the same, so we're going to rewrite one of the base. And we're going to decide whether we need to add the powers or subtract them. So let's just use my reading here. Because we're dividing, the rule says we're going to subtract the powers. Here, so this is going to be subtracted, and then because we multiply, we're going to be adding the powers here. So there's a clash of sign right here. And then on this side, we have y to the 4. Because you're dividing, you're going to subtract the powers here. And then on this side, you're going to add the positive 3 here. All right, so we're going to rewrite what we have here. So for the first a, we have negative 2. We're going to minus the 1, and we're going to add the negative 1 to this here. Add the negative 1 to this here. And then for the y now, we're going to end up then with y raised to the 4. And then we're going to minus the negative 5 from here. And we're going to add the 3 here. All right. So then finally, then we're going to end up with 15a. And you can use your calculator and just apply this all at once. So that's minus 2 minus 1 is minus 3. Minus 3 plus this positive with negative gives a negative. So that's minus 1. Minus 2 minus 1 is minus 3. Minus 3 minus 1 is minus 4. And then we're going to have y. This one is going to be negative by negative is a positive. 4 plus 5 is 9. 9 plus 3 is going to give us 12. And that's what should have been your answer. So essentially, guys, if it is that you are not able to do it mentally, because if I am doing this math problem on my own, I wouldn't be going through all this process, because I would have had a fundamental foundation on integers. But some of you guys are still struggling with this area, so you need to lay it out like that so you can clearly see where the clash of signs are. All right, so I hope you guys understand finally. And then now going forward, when you see this again, you won't make the errors that you made on that examination. Okay? All right, so good. We're a little bit over, well, we're almost over an hour and a half already. But let's continue. Here we go. So now we're moving on to pool 2. So pool 2 is another group of students that I have. They are currently doing, as opposed to doing algebra, they're doing measurement, right? They're doing measurement. And so it says here that the shape below, which I'm going to draw in a second. So let me just clear my screen here. Can I clear my screen? I don't have to. Let's just move this document right over this side here. So we can get some more space on this side. And then we're good to go. All right, we're gonna zoom up here. All right, here we go. Let's zoom it up a little bit. Good. And let's just clear up these markings here. All right, here we go. No, I've decided not to draw the diagram prior to making the video because I want you to show the construction of what I'm doing. So it says your question for only pool 2 should answer this question because they're the only group that's doing measurement. So it says that the shape below represents the uniform, let's underline this word, uniform, floor plan of a section inside a building with the given dimensions below. Your task after observing and analyzing the diagram is to determine the area and the perimeter of the shape. So let me go ahead, guys, and construct the shape that the students were looking at, right? And this is a composite shape. So here we go. All right. So what we had here was a straight line. Oops, pardon me. So let's construct this together, guys. We have a straight line here. All right. And then we had another one coming down like that. And we also had another one coming down like that as well. It's not giving me the straight line that I need. Okay. All right. Then it came in like this a little bit. Oh, that's a little bit too far. So it came in like this. And then this one came in like that. Something like that. It's not perfect, right? Right, so it's like that, okay? Then it came, so it basically looks like the letter I, pretty much. And it comes down like that. Not really, it's not drawn to scale, guys. So bear with me, then we come across like that. So it's pretty uniform. I don't know if it's exactly dead straight. Okay, guys, work with me. All right, so it's not perfect, but essentially this is the idea of what they were looking at. Okay. Essentially, this is what we're looking at, right? And so on the diagram, there were some measurements that were given. Now, before we get into the measurements, there was some what I call nonverbal communication, right? So we had a stroke here, one here, and one here. We had a double stroke here as well, and one here as well, and here, and here, right? And the measurements that we had on the diagram was, let me just use a different color ink. We had 15.8 centimeter. We had 3.5 centimeter. We had 5.7 centimeter, and we had 8.6. Sorry, guys, we had 8.6 centimeter, right? And there was some extra little stuff on it as well. So I also did some lines like I would say to them that this side all the way down here that's where the measurement of 8.6 is, and from here to here was actually 5.7. From here to here was the 3.5, so they could understand this point here from this point here was 15.8. I actually think I had this 15.8 down here, but it's essentially the same thing. All right, so I think on the exam I had this 15.8 written down here. I think I should do that. I don't want to throw you guys off thinking that it's a different question. So on the actual exam paper, I believe I had the 15.8 down here. All right, so the 15.8 was right here. All right, and then I had the line like that. Yeah. Oops, pardon me. So this was from here to here. All right, so this is the diagram that the students were looking at the time when the exam was being administered. So therefore then, how would we go ahead and find the area and perimeter of this shape? Let's start by finding the area. All right. Now, to find the area of a composite shape, and if you recall in our measurement video or measurement tutorial, we discussed in part 1 and part 2 that a composite shape is a shape comprised of more than one of the base shapes. So it could be 3 rectangles, or a square in a rectangle, or a circle within a rectangle, or a circle within a square, or a square attached to a circle. It's pretty much like that, right? So what we have here is basically the letter I, right, being constructed by using a rectangle, a horizontal rectangle, resting on top of a vertical rectangle that is sitting on another horizontal rectangle. So when you get questions like these, guys, what you want to do is you want to make an effort to cut the diagram up in pieces. So I'm going to use this dark purple here, or should I use this one here? Okay. So what we want to do here, guys, I'm going to zoom it up a little bit here for you. Okay. This particular video is not a video that is just going to demonstrate how to get the answer, but it's going to demonstrate how to think. Okay. So pay close attention, guys. We have a choice. We can cut it up like this. Now let's cut it up the correct way. So the best way to cut it up is like this. We're going to cut it here. And we're going to cut it here. So when you cut it like that, it gives us 3 shapes. We get a rectangle at the top here. We're going to call it rectangle A. We have a standing rectangle here. We're going to call it rectangle B. And we have a lying down rectangle here. We're going to call it rectangle C. So if you want to set up the working out like a general student, like a student who really is going to work out the question according to how CSEC wants it, then what you want to do then is that you want to set up a little guide. You want to say area of shape, right, is going to be equal to the area of A plus the area of B, of not D, pardon me, of B plus the area of C. All right. And then what you're going to do is proceed to find the areas each. So now we know that all 3 shapes are rectangle. So essentially, it's going to be length times width plus length times width again, plus again length times width. All right. Now bear in mind that the length for each shape is going to be different. So if you look carefully, right? Look carefully, because this is what I think that majority of CSEC students struggle with, is not only comprehension, because that's one of the biggest problems, but also observation, right? Transfer of learning. So here's what we're going to do, guys. We're going to go here, okay? And what you're going to notice, guys, is the area of this triangle up here, it's a rectangle, is actually going to be length times width. So the length would have been this long side here times this short side width right here, which is 3.5. So I don't really have this side, or do I? Remember that they said that it's a uniform shape. So even though you may not see an indicator to say this bottom side here is equal to this top side here, then you have to assume, right, that they run from this edge to this edge, and this is running from this edge also to this edge in alignment. So this naturally has to be 15.8 centimeter. All right. Now you notice that one is on the top and one is on the bottom. So you could simply say that the area of A and B, area of A and C, we could find them both at the same time. Because it would be the same measurement, because remember that this is also 3.5 as well. How is that 3.5, Mr. Peart? Because remember, we have those little red lines. You see these red lines right here? That red line here, that red line here, this one right here, and this one right here. That's CSEC's way of non-verbally telling you that all 3 sides measure the same. So this would be the length, and this also would be the width. So the area of A is basically the area of C. So all I have to do is find the area of A and C. All right, and the area of A and C would simply be the area of A times 2, or the area of C times 2, if that makes sense. All right, so the area of A is going to be, area is going to be length times width. So that's going to be 15.8 multiplied by 3.5. So let me just quickly grab my answer sheet, because I had it yesterday before. Let's grab it here, guys. 15.8 times. Okay, so 15.8. Okay, let's just go on our calculators, guys. Okay, I don't want to use my answer sheet. So 15.8 times 3.5, 15.8, 15.8 times 3.5. right? And essentially we get 55.3, right? So that would be the area of A, no? 55 point, how much did we get a while ago, guys? Just let me, 55.3. So 55.3, so this would be 55.3 here. And remember that that's just the area of A. So if I times this by 2, I would naturally get the area of A and C because they're essentially the same shape with the same measurement. So then this would be 110.6. All right, squared centimeters. So that would be the area of A and C. So I can go down here now and I can just write area of A is 55.3. All right, I already know it's 110.6, but I'm just going to just work it out here, 55.3. Right, so all I need now is just the area of B, which is this side, that shape that is in the middle right here. So let's grab a different color ink here, and we're going to find that shape right in here. Okay, so this is the shape I want to find here. So once again, it would be just this length right here by this width right here. Now, the challenge with this is that we don't know what this blue broken line measures. But what we do know is that this here and this length is the same, so 5.7, right? And we know that all the length is what? 15.8. So if we have 5.7 and 5.7, all we have to do to get this blue broken piece in the middle here is to go ahead and then say that's going to be, just give me a second here. Let me just grab the screen. Okay. So all I have to do now is just to go ahead and find this little piece in the middle here. So to find this, and remember, you're not going to set it up like what I'm doing here, guys. This is just me teaching you. So before I can find the length times width, I need to find the actual width, right? So the width is going to be 15.8 minus 5.7 plus 5.7, which is basically 5.7 times 2. 5.7 times 2, like that. So 15.8 minus 5.7 times 2, that's going to be 11.4. And then if we subtract that, then we should end up with, let's see, 0.6. That's 3.6, 4.4. All right, so what we're seeing then is that this length right in here is 4.4. All right, so the width of that is 4.4, so it's going to be 4.4. All right, so let's, before I write it in here, the width of that is going to be 4.4. So then it's going to be 4.4 multiplied by the 8.6 right here. 8.6. That's going to give us the length times width. So this is going to be the width and that's going to be the length. Okay. So hopefully you guys are following and it makes sense. This is the thought process behind what we're doing. All right. So if we're going to calculate that's 4.4 times 8.6, 4.4 times 8.6, 4.4 times 8.6, 37.84. All right, 37.84. So we drop that. We just drop that right into 37.84. All right, which essentially I'm just going to add it to here, 37.84. All right, so it's kind of like the same. So it doesn't matter how you work it out. So if you add all three of these, you're going to get the full area and it's going to be equal to this as well. So 110.6. So 110 plus 110.6. We just add both of them together, we get 148.44. So therefore, then the complete area of this shape, and I know you're probably wondering, all that work just for 2 marks? I was a little stingy when it comes to giving the marks, but essentially, because I knew that the area of the top was equal to the area of the bottom, all it requires was this. The only bit of calculation that you would have needed to do was this section right here, where you had to find that little middle blue piece right there, and then you had to think intuitively. So that's 144. So the final answer then for the area is going to be 144.84. 144.84. Let's double check that and make sure that we have that right. 0.44, not 84. My bad. So 44, not 84. So 44. Right? And then the perimeter now. Finally then, the perimeter. So all of that, believe it or not, guys, I only awarded the students with 2 points. Because if I'm to zoom out and you realize that everything down here is kind of like just the thought process. You didn't have to send me this information. All that was needed was really this 15.8 times 3.5 times 2, plus you would have worked out this little piece down here. So, I could have given you 3 marks, but nevertheless, if I gave you 3 marks, I still would have marked it out of a higher grade. So it's not going to really make much of a difference. All right, in my opinion. All right, so here we go. So that's it. All right, so in terms of the perimeter now, guys, remember that perimeter means the distance around. So let's look at shortening the working out here, guys. Remember now, we're going around the edge of the shape, not inside the shape. So let me just grab a reading here for you. So essentially what we're looking at is 15.8 times 2, because it's 2 of them, top and bottom. Then we have what? 3.5 times 4, because 1 is here, 1 is here, 1 is here, and 1 is here. No? So that's 3.5 times 4. So let's write that down. 15.8. Instead of saying 15.8 plus 3.5 plus 5.7 plus 8.6 plus 3.5, then we're going around in circles. That's too much. So you want to be more concise by just saying, okay, these are top and a bottom. So we're going to have perimeter. Okay. Oops, pardon me. Don't know what that is. Okay, here we go. So perimeter is therefore equal to 15.8 times 2 plus 3.5 times 4, because it's 4 of them. And then remember that we have 4, 5.7 as well. 1 is here, 1 is there, 1 is right here, and 1 is right here. So that would be, again, plus 5.7, 5.7 times 4. And then we remember that we have 2 8.6 right here. So 1 is over here and 1 is over there. That's plus 8.6 times 2, because it's 2 of them. All right. Now, because of saving time, I had already done the calculation, and then we had end up, see here, wait, let me just double check. 3.5 times 4, 15.8 times 2. 5.7 times 4, 8.6 times 2. When I checked it up, guys, I end up getting an answer of 85.60. All right, so that would be the answer, 85.60. That's the perimeter of the shape. All right, beautiful. So, this is what CXC is looking for. If you're looking to say you want to convert yourself into a distinction student, CXC is looking for these markups and these things. That's essentially what you're looking for, right? They want you to see and understand that this is how you think through the problem. All right. So what's the hard question? Let me know in the comments. Okay. Let's move on then now to finding. Let's see here. The dimensions, the area and the perimeter was calculated. So here, area and perimeter was calculated. Good. Now it says that the floor, let's zoom up here, guys. So it says that the floor is to be covered with flooring boards measuring 2.5. So basically, we're going to be putting some flooring boards. So basically, it's a floor plan. So it's an overview, or it's a top view of what the inside of the building is going to look like. Maybe it's 2 hallways or 3 hallways meeting, and they want to tile it out using flooring boards. Each flooring board measures 2.5 square meters. This was a mistake. This should have been centimeters, guys. I don't know how many of you guys recognize that that was a typing error. So that should have been 2.5 square centimeters, because the measurement is in centimeters. Calculate the number of flooring boards needed, or that are needed, to cover the entire floor. So here's the understanding behind what is happening, guys. What we're basically saying then from this question, if you guys are unable to see these things, guys, what we're basically doing is we are wanting, right? Anybody who wants to go into masonry or carpentry or building house, building tech, these type of math is going to be your best friends. All right. So essentially what we're doing, guys, is we are going to be covering, I don't know if it's going to be small like that. So we want to find out how much flooring boards are going to be needed to cover the entire floor, going all the way through like that. Right. So I don't know if it's going to be a lot of flooring boards, but basically we want to tile it out, basically. That's what's happening. All right. So we're going to tile it out like that. But we know that each flooring board basically measures 2.5. So each of these measures what? 2.5. So basically, the math is not that simple. It's not that difficult. It's just the understanding behind it, because Since as we already know that the area is what? 144. What's the area? Not the perimeter, but the area, guys. What's the area? Here is 144. Was it? 148.44. All we have to do, guys, is just divide this by 2.5. How many 2.5 boards can we get from the total area of 144 point this? So 148.44 divided by 2.5. 148.44 divided by 2.5, and you realize that we need approximately 6. Well, we could get 59 is the amount that we need, but if we get a 60, it won't. Maybe we have a damaged one and we need to fix it, but essentially we need approximately 59 boards to really tile out the entire floor. All right. So a lot of the times, guys, when you see a CSEC question, I think it's really challenging. It is really far simpler than you think it's going to be. So 59 boards is required for this tiling. All right, lovely. All right, good. So we are getting to the end of the paper, guys. I know it's a long video, but essentially, guys, the grades that you got, you realize what you needed to do to get the grades, the amount of thought process. It isn't as easy as you think it is, but it is easier than you thought it was, if that makes sense. Let's say that again. I think that's funny. So it's not as easy as you thought it was, but it's not as easy as you think it is, but it's easier than what you thought it was. Don't know if that makes sense, but anyways, let's get on. All right, so next question is, given that a triangle has an area of 74. So this is a worded question then. All right, no diagrams to support us, so we've got to use our imagination. Okay, so now we end up with, given that a triangle has an area of 74. So we're being told that the area is, so we're being told the value of A. And its height, notice again this non-verbal communication where we have bold the words, certain words, it's bold. That's a way that CSEC tries to communicate with you, to send you information, right? Now, in our measurement class, I believe it was part 1? I believe it was part 2. We discussed that the only triangle that has a base and the height is in fact this triangle right here, this right angle triangle, right? So you would have had to assume that the triangle that they're talking about here is a 90-degree angle, because remember, guys, a height cannot exist without a base. And if a height is involved, there has to be a 90-degree, and there's only one triangle with a 90-degree in it, and that's the right angle triangle. So right there and then you can even create an image in your mind. We know that inside here will measure 74 square centimeters, right? And we know that the height is 17.3. So that's right here, 17.3. From here to here is 17.3 centimeter. And then obviously right here is missing, which is the what? Base. So they said determine the base length. So remember the number one rule when it comes to words questions like these, you're going to write down your formula. A is equal to base times height divided by 2. I saw quite a few students trying to use Heron's formula. Remember, Heron's formula is used for finding the area of a triangle when all 3 sides are given. And a few persons try to use the sine formula as well. We don't have 2 sides. We have one area and we have one length. So if you try to use those formulas, you'll understand why you would have gotten the question incorrect. Okay, so area is equal to base times height divided by 2. So therefore, area, we are told that the area is 74. You're going to place the 74 underneath the letter A. All right, this is what a lot of students lack. They don't know how to reverse the formula. So 74 will be placed under the letter A because that's what we're told. The base is unknown, but the height is 17.3. And we're going to divide that by 2. All right, so 17.3 divided by 2. Let's grab our calculators here. 17.3 divided by 2. Oops, sorry. 17.3 divided by 2. Oops, divided by 2. That's 8.65. So 73 divided by 2. This is this part right here. All we have here, guys, is 17.3 divided by 2. So that's the only thing that can be done right here. So then we're going to have 74 is equal to the base times 8.65. And to isolate the b from here, all we have to do is basically 74 divided by 8.65. Oops, pardon me. 8.65. So we're going to just erase here. 8.65. 8.65. That's going to be equal to B. Right? Divide both sides by 8.65. So 74 divided by 8.65. 74 divided by 8.65. So we get a measurement of 8.55. 8.6 pretty much. All right. So therefore we are saying that this height, this base here, so is 8.65. 8.55, 8.6 centimeter. All right. So in terms of the calculation, evidently you can see that it is not a challenging question, but it does require some level of thinking. All right. Lovely, 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 lovely. All right, let's bring this video to the end, guys. Let's get into the latter part of this paper here. So we finished with page 2 of this question. All right, let's get down here. I can't find it. Where is it? Let's see if we can you help me find it, guys? Oh, it's all the way down here. Okay. And we already have our graph drawn up here. So we're on this part of the diagram here. All right, here we go. All right, so now we're looking at this one here. It says that, all right, and then another thing that I like to also put on my test papers is the fact that CSEC loves to kind of make the math look realistic. So what we're looking at here is a flower's garden is in the shape of a triangle. At this stage, reading this part of the question here, we don't know what type of triangle it is. It says a triangle. So it could be isosceles, it could be a scalene, it could be right angled, it could be equilateral. What gave the question away was the fact that all three measurements are different. And if all three measurements are different, pretty much what you're looking at then is more than likely a scalene. Here's the fun fact. This diagram was drawn for my students. So all my students would have seen this shape on the board or on the exam paper. And I believe that I would have placed 9 centimeter here. I think I would have placed 18 centimeter here. And I would have placed the 13 here. So at this stage, you're looking at this triangle. Can we use half base times height? That's not possible because you might want to consider this to be the base, but what's the height? Remember that a height has to be vertical. It has to say that one of those heights, because we can have 2 students working the same question and one student chooses 13 as the height and another student uses 9 as the height, and they end up with 2 different answers. So in this case, there is not an indicated height. Therefore, half base times height is not applicable. So then we have to run to this formula here where we see square root of s bracket s minus a, s minus b, s minus c, and that's going to be equal then now. And we know that we're going to have to find s. S is equal to a plus b plus c divided by 2. All right, I have a tutorial coming out. Obviously you're seeing this video on a Tuesday evening. Well, at least the time when it was posted was Tuesday evening. But essentially at the time of watching this video, I'm going to be posting an online recording of how to work out the Heron's formula. So stay tuned, look out for that. Hit the subscribe button and enable your notification to be notified whenever I post. You'll get that tutorial video in depth. All right. So here we go. So we're going to go ahead and find S. S is equal to, we're going to go ahead and label our sides as A, B, and C. Any side can be A, B, or C, guys. So this is going to be 9 plus 13 plus 18. That's going to be divided by 2. When you add those, you're going to get 40 divided by 2. 9 plus 13, that's 22. 22 plus 18, that's 40. 40 divided by 2 is 20. So the semi-perimeter is 20. All right. If you're in my class at this point, no problem with this. All right. You should know what that means. All right. And then obviously, we're going to go ahead and place it into the main formula. So that's the square root of 20. Open bracket, again, S is going to be 20 minus A, which we know is going to be 9. So that's 20 minus 9. Oh, don't know why I'm writing so bad. So 20 minus 9, 20 again. So this is this S right here, 20 minus this B, which we don't know is 13. So that's 20 minus 13. Open bracket again. We're going to have 20 minus C value, which is this 18 right here. All right. Now, we know that bracket means multiplication. So evidently, it's going to be 20 times. I saw quite a few students adding. It's kind of crazy, right? Bracket means to multiply. So once you see here, number outside the bracket is used to multiply. So 20 times 11 times 7 times 2. When I did the calculation, I got 3080. You guys can confirm with me in the comments if that is right, because I'm not using my calculator. And then I end up with 55.42. I think that's what I ended up with. Don't quote me, guys, because I'm not using my calculator. Let me just check my answer sheet here. 55.5. That's what I got. Right? 55.5. Yeah. 55.5 centimeter. All right. So that's what we got for that question. All right. So basically, don't worry about it being a garden. It's just a way of CSEC trying to convert the math problem into something more realistic and applicable. Okay. All right, so it says that we should determine the area of the garden. We've done that. It says the distance around the edge of the garden. That was kind of like a little bonus question just to give you a mark, because we would have essentially found that the distance around would have been 40. Remember that in the formula, we were required to find the semi-perimeter. So we would, the semi-perimeter, before we found the semi-perimeter, which is 20, we would have needed to find the perimeter, which is 40. So if you want to go ahead and just add that here, it's going to be 13. Whoops. Pardon me. Whoa. Okay. Let's close that note. So if you wanted to go ahead and like do extra working out, that would have just simply been 13 plus 18 plus 9, which is equal to 40. All right. Centimeter. Okay. Lovely. All right. Lovely. So now we're at the last lap now, guys. Again, if you have not or you've reached this far in the video, do not forget to hit the subscribe button below. Leave a comment, leave a like, share this out so other students like yourself who is struggling can get the assistance that they need. This is the only channel that provides students with review assessment papers, class after class after class. I'm very close to 1,000 subs. Let's get it over to 1,000 subs by the end of the year, guys, and let's start the new year with a bang. Okay, let's go. Given that the points 2, -5, so we also introduced the concept of graphing. Given that the points P, -2, 5, and Q, 4, 1 forms the line PQ. So basically this forms a, whoops, pardon me. So this basically, these 2 points basically forms the line PQ. And then we have these 2 points here that forms the line AB. Now, I will leave a link that is pinned in the comments and also in the description of this video. I will send you to my part 1 and, well, part 1 for this particular paper, but I'll send you to part 1 of my coordinate geometry video where we can get more elaborate knowledge on this. For this particular video, I want to bring it to the end, so I'm going to move a little bit fast in terms of getting to the result. All right, it says plot the points above on a carefully drawn Cartesian plane and draw the respective lines that correspond with the points. Bear in mind that points are awarded for properly labeled axes and neatness. Okay, we spoke about this. All right, and so if we scroll across here, you'll realize that I've already designed some sort of Cartesian plane here. All right, so I've drawn one for you. I couldn't actually get a graph paper, so I had to use a template for this. All right, a template. So bear with me, guys. Let me just quickly grab the points from up here. What are the points? We said that the points were what? -2, 5. Is that what it was? That's P. And Q is 4, 1. I want to grab them so I don't have to go back up there and look. And then we end up with A. I didn't leave it as A, but I did correct it as 1, -1. And then we have B, which is -5, -6, -5. comma, -6. All right. So we're going to zoom back out now to here. And then we're going to just use this here. All right. So it's a template, guys. So don't really matter. Don't worry about the instructions. I'm just going to go over here and plot in those points right here. So I made a section where I could put the points. So P is going to be equal to -2, 5. Q is equal to 4, 1. And then we have A, which is equal to 1, 1, 1, -1. And we have B being equal to, oops, pardon me, B being equal to -5, -6. Okay, so that's -5, -6. All right, so we're going to plot these. All right, now, like I said, I don't have an actual graph paper template. I'm going to try to work one to get it on my system. But for now, let's go ahead and improvise here. All right. Over here. So you would have drawn up an X and Y axis, and then we're going to go ahead and label it. So this would be, say, 1. Oops, pardon me here. Let's see if we can do this good, guys. 1, 2, 3, 4, 5, 6. We're going to have 1, 2, 3, 4, 5, 6. Not perfect, but you follow me. 1, 2, 2, 2, 2. Okay. 3, 3, 4, 5, 6, 7. All right. And then we have 1, 2, 3, 4, 5, 6, 7. All right. So it's not perfect, but I hope you guys get the idea. And I also remind you guys that if it is that you are watching this video, you should have your test paper in your hand observing. All right. So here we go. First point, -2, 5. I'm going to take 2 steps to my left. So that's -2 right here. And 5 is going to be 1, 2, 3, 4, 5. 5 is going to be up here. So I should be in somewhere around this position right here. Let's double check it. Should be about here. All right. Not too saucy. About there. Somewhere there. About here. About here. All right. Not exactly, but you got the idea. And then 4, 1. So that's 1, 2, 3, 4, and up 1. So we should be right here somewhere. So 4, 1. Somewhere there. All right. So this would be the point A. Sorry, this would be the point P. And this will be the point Q. All right. We'll just connect these two like that. That should be the point that you should have. All right. And then now we're going to go ahead and we're going to look at the point A. So point A is going to be 1, -1. So that's 1 to my right, 1 down. Should be about there. That's point A. And then we're going to have the point B, which is -5, -6. So that's -3, 4, 5. That's -5. And then down -6. 1, 2, 3, 4, 5. This is -6 right here. So we should be about here. If I stand corrected, about there. Should be about there, right? So we should end up with a diagram like this right here. Something like that. And then this would be the point B. And then this would be the point A here. So if you have something looking very close to that, then you are doing pretty good. All right. So for neatness, I give you 3 marks to plot the points. Points is labeled. So you would have been neat. All right. Lovely. So now, next question then. Let's go back up here. Should have had that. So plot the points, which we did, above carefully on a carefully drawn Cartesian plane. Draw the respective lines and correspond with the points. Points are awarded for properly labeling the axes and neatness. 3 points just to do that. Use the graphical method as well as the formula. I didn't write this question so well because some persons who prefer the graphical method use it for both. Other persons who prefer the formula use it for both, right? So if you use one or the other, perfect. If you use both, I didn't really kind of crucify my students because the wording of the question was kind of ambiguous in terms of telling them exactly what to do. What I wanted them to do was that I wanted them to use the graphical method for 1, which would have naturally been for PQ, and then use the formula for AB, right? But some of them use the formula both of them, and some of them use the graphical method for both. So for this particular video, I want to demonstrate the use of the formula and the graphical method. So I'm going to use the graphical method for PQ, right? So that's the graphical method. And then I'm going to use the formula for AB. All right, so for the graphical method for PQ, let's scroll down here. I'm going to zoom it up now so it gets a little bit bigger. So the graphical method now, remember we said in the class, right? And if you watch my tutorial video, we said that the gradient M is equal to rise over run, right? And rise is the vertical distance, run is the horizontal distance. So if I wanted to, I could rise from Q and run towards P, or I can negatively rise, all right? Or I can rise down, as some birds would say, and run towards Q. For this one, I'm just going to rise from Q. So I'm going to write, let me just grab a reading here. I'm going to rise from Q. I'm going to go up like that, broken lines up like that. Rise up like that. And you have a rule like going to run like that. Broken lines, all right? So something like that, neat. Right, I'm going to get a perfect template so that it makes sense. So it's actually going through. So what I'm going to do is that I'm rising. I need to know how much I'm rising. I'm going up. So I'm in line with this point right here. So I'm going to go 1, 2, 3, 4. So I'm rising positive 4. So I'm rising. So I'm going up 4. And I'm running. So I'm in line with here. I'm going to be running now 1, 2, 3, 4, 5, 6. I'm in line with here. So that's negative 6 because I'm running to my left. All right. So that's negative 6. So therefore, then the gradient would have naturally been, say here, the rise is negative 4 and the run is 6. Sorry, the rise is positive 4, pardon me, and the run is negative 6. If you reduce this fraction, a lot of person didn't even reduce it. I still gave them the mark anyways. They should have really reduced the fraction, so the answer should have actually been negative 2/3. That's for the formula. Sorry, that's for the graphical method. All right. So once you do that, like I said, guys, take the time out. If you have problems with coordinate geometry, take the time out and just watch the video that is linked in the comments, and it will give you a full explanation on the whole rise and run concept. All right. Now, like I said earlier in the video, some persons, what they did was that they used that same formula to find, they use the same, so upon making this video, guys, I just saw a notification from a CSEC math instructor about the new syllabus. So remember, guys, this is really good news. Well, good news or bad news, I don't know. I just saw a notification on YouTube stating that the new syllabus is going to be explained. So I'm going to be watching that video shortly to understand how the new syllabus for 2026 will be set up. All right. So, guys, you need to pass the exam this year. This is the year. Or else next year, you're going to meet up on a new regime, and it's going to be all chaos for many persons who already are not a big fan of math. And so here we go. I'm so excited to go and watch that video. So let's get into it. All right. So for this one, I'm just going to use the formula here. So the formula then is going to be M is equal to y2 minus y1 over x2 minus x1. All right. And we already know what the points are for that. We're going to go over here and we're going to label it as, let's go over here, guys. So for this is going to be x1, x1, y1, x2, y2. X1, y1, x2, y2. So based on this, then m is going to be equal to y2. Based on y2 here, that's going to be negative 6. Y1 is going to be negative 1. So that's minus 6 minus 1 over x2, which is negative 5, minus x1, which is 1. So that's going to be equal to negative. So negative by negative is positive. Negative 6 plus 1 is negative 5. And negative 5 minus 1 is negative 6. This reduces to positive 5 over 6. So that is what would have gotten you your answer. All right. And then now what we needed to do finally we've gotten to the end of the video, was that we needed to determine the length of PQ. So we wanted to find the length of PQ and the length of AB. Fun fact is that you could have actually used your ruler on your graph paper to get this answer. But I would have wanted them to use the formula because that's what we are currently discussing in the class. So let's go ahead and find the length of this line. So again, square root, pardon me, that the length formula is y2 minus y1 squared plus x2 minus x1 squared. That's the formula. All right, now what I always tell students is, if you're in an exam where you end up finding the gradient of a line and you're also asked to find the length of the same line, the length of the line and the gradient of the line has some sort of connection. And what that means is that since I've already calculated y2 minus y1, right? So since I've already calculated y2 minus y1 here and x2 minus x1 here, and also for here, this would have been the rise, this would have been the run, right? All I have to do is just go ahead and find the square root of -2 squared plus 3 squared. That would have naturally been it. So that's going to be the square root of 4 plus 9. So the answer is going to be root 13 units. All right, that's essentially the answer. All right. So the y2 minus y1, right? We can double check on that too. The y2 minus y1. Remember that y2 here for this one, x1, y1, x2, y2. All right, so look at this now. Y2 would have been 1 minus 5. So if we write the formula here and we say it's going to be, let's get some space here, guys. Hold on, give me a sec. Let's do it the right way. Let's not rush it, right? So here, let's say we have the formula, square root. Sometimes I do tend to rush, make a mistake. So let's go ahead. So square root of, so the square root of y2 minus y1 squared plus x2 minus x1 squared. All right, so I think what I did here was I should have squared the value. So let's go. Y2 is 1. So that's the square root of 1 minus y1 is 5 squared plus x2 is 4. So this is what I'm looking at, 4 minus x1 is -2 squared. So if you look at the math now, we end up with -4 squared plus, this is going to be 6 squared because 4 minus times minus is plus. So 4 plus 2, that's going to be 6 squared. So we end up then with the square root of 16 plus square root of 16 plus 36. So that ended up with the square root of 52. All right. So let's check if the square root of 52 is the same thing as the square root of 13 or root 13 units. Let's see. Let us see. Square root of 13, square root of 52, square root of 13. Square root of 13 is this number, 3.6. And the square root of 52, square root, I think we're getting incorrect, square root of 52, 7.21. So I think that I made a mistake. Don't do this method, guys. Let's go back to it. Don't take the shortcut and just use the gradient here. Work out the formula step by step and get to your answer here, okay? So avoid this. Let me just erase it. Do not do this shortcut here. As you can see, I made an error here. Use your formula, all right, to get the correct answer, all right? Good. So the answer is square root of 52. All right, and you can write down the decimal value if you want to. Okay, and then now essentially we do the same for this. It's going to be the square root of y2 minus y1 squared plus x2 minus x1 squared. All right, so in this case now, because, all right, so in this case now, right, I wouldn't use the rise of our own value because I've already worked out y2 minus y1, I would have gotten 5. Y2, look at this, guys, y2 minus y1, I would have already worked that out and I would have gotten 5 right here. So I could just go ahead then and just say the square root of 5 squared plus x2 minus x1, I would have already worked it out down here. x2 minus x1, x2 minus x1, that's 6 squared. Okay? So then I could go ahead then and just say 25 plus 36. And so my answer then would have been the square root of 61 units. All right. All right, guys. It has been a very lengthy video, but I trust that with this thorough, in my opinion, thorough explanation of the question, you can see that a paper that should have taken an hour and a half to work out in terms of giving you the answer, I had to do a bit of excessive talking to ensure that going forward, you guys do not make those silly mistakes that I unfortunately saw on the paper. All right. So I hope that you guys enjoyed the video regardless. I hope that it helped. Your next test is going to be October the 29th, which more than likely you're going to be seeing the video during the course of the first week of November. So let's get cracking, guys. CXC is around the corner. It's no time to waste. And like on the paper, what we see here on the exam paper, let's zoom it out here and end the class in this. End of assessment. All the very best. You are what you believe. Have yourself a good afternoon. Take care, and I'll see you in the next tutorial. Bye-bye.